Welcome back to Tales of Chemistry. Today we are going to discuss organic compounds containing nitrogen, part 5, the last part, which includes the preparation and properties of diazonium salts. Diazonium salts are salts which contain aromatic ring, the benzene ring, with N2 and X minus. So Ar, N2 plus and X minus, this kind of salts are called diazonium salts. We will have to study only about C6H5, N triple bond N, Cl minus, that is benzene diazonium chloride. Now, let's see how is this benzene diazonium chloride prepared. So, you need aniline, C6H5NH2. This is aniline. Treat aniline with HNO2, which is nitrous acid. But nitrous acid is unstable. So you need to prepare HNO2 by mixing NaNO2 and HCl, dilute hydrochloric acid. Therefore, HNO2 comes from NaNO2 and HCl at very low temperature, 273 to 298 Kelvin or 0 to 5 degrees Celsius of temperature. Now, the product of this reaction is C6H5, that's a benzene ring. With that, N triple bond N Cl minus. This is benzene diazonium chloride along with NaCl and water. All right. So this is the method of preparation of C6H5N2Cl, that is benzene diazonium chloride. This equation is a very important equation. Now, the major reactions including diazonium chloride are the first one, Sandmeyer's reaction. Sandmeyer's reaction. In Sandmeyer's reaction, benzene diazonium chloride is treated with CuCl, cuprous chloride, in HCl to give us chlorobenzene and nitrogen. If the same diazonium chloride is treated with cuprous bromide in presence of HBr, then the product is bromobenzene along with nitrogen. Now, the same reaction, that is diazonium chloride, if treated with cuprous cyanide in presence of KCN, potassium cyanide, then the result will be cyanobenzene and nitrogen. So these three reactions are examples for Sandmeyer's reaction. Treat diazonium chloride with cuprous chloride and HCl. The product is chlorobenzene. instead of cuprous chloride and HCl. If cuprous bromide and HBr are taken, then we get bromobenzene and nitrogen. If cuprous cyanide and KCN are used, cyanobenzene and nitrogen are the products. That's about Sandmeyer's reaction. The next one, Gattermann reaction. So in Gattermann reaction, it's very similar to Sandmeyer's reaction. The only difference here is you don't need a cuprous salt. Instead, we use copper directly. That means take benzene diazonium chloride C6H5N2Cl, treat it with copper in HCl. The result will be chlorobenzene, nitrogen, and cuprous chloride. Chlorobenzene, nitrogen are the main products here. And if you use copper in HBr, you will get bromobenzene, nitrogen, and CuCl. Bromobenzene, nitrogen, CuCl. Finally, that is about Gattermann reaction. Okay, so the difference here is use diazonium chloride, but instead of cuprous chloride or cuprous bromide, use copper directly. You will get chlorobenzene or bromobenzene. Now, the third reaction that we need to study here is replacement of N2Cl by iodo group. So take out N2Cl, replace it by iodo group. In this case, treat benzene diazonium chloride with Ki. Benzene diazonium chloride is treated with potassium iodide and heated. The product or the products are C6H5I, that is iodobenzene and nitrogen. Iodobenzene and nitrogen. Now, the next reaction is again a named reaction. It is called Boltzmann reaction. In this reaction, you are replacing N2Cl by a fluoro group. This is replacement of N2Cl by a fluoro group. Now, here what we need to do is treat benzene diazonium chloride with HbF4, which gives to an intermediate. A reaction intermediate is obtained where you will have your N2 with BF4 minus. Now, on heating, this intermediate decomposes to give you fluorobenzene plus BF3, nitrogen, and HCl. So this is called Boltzmann reaction. Alternatively, this reaction you can write without mentioning the intermediate. So what you need to do, this is keeping the board examination in mind, all right? So write benzene diazonium chloride gives, first of all, write number 1 and write you're treating it with HBF4. Number 2, you are heating. So this clearly tells initially you're treating with HBF4 and whatever product you get, that is heated. So then just copy the products. Fluorobenzene, BF3, nitrogen, HCl. These are the products. So you can skip if you find it difficult to remember the intermediate formula. Just skip it, but write number 1, HBF4, number 2, you are heating. Okay, that is about replacement of N2Cl group by fluoro group. The next reaction, this is very important, replacement of N2Cl by hydrogen. Replacement of N2Cl by hydrogen. So in this, we are taking diazonium chloride, benzene diazonium chloride. Treat this with the ethyl alcohol. So we are treating this with C2H5OH, ethyl alcohol, and the product that you get are benzene, CH3CHO, acetaldehyde, N2, and HCl, CH3CHO, N2, HCl, along with benzene. All right, so that's how that N2Cl is replaced by hydrogen. Now, in this, there's one more reaction that we need to study, that is reaction of diazonium chloride with warm water. That is reaction of C6H5N2Cl with warm water. In this case, that N2Cl is replaced by OH group. That is, we are preparing phenol here. We are preparing phenol. Let's see how this reaction takes place. Benzene diazonium chloride, that is C6H5N2Cl, benzene diazonium chloride. Treat this with water. Treat this with water, which is not cold. Then the product that you get is OH here, which is phenol, and N2 plus HCl. So in this, we have studied how can we convert diazonium chloride, benzene diazonium chloride, to chloro or bromobenzene. We know how to convert it to cyanobenzene, to iodobenzene, to fluorobenzene, to just benzene and phenol. These are all important reactions of benzene diazonium chloride. Now, another set of very important reaction. It is called coupling reaction. Coupling reactions. Under coupling reaction, we need to study two and both reactions are equally important. So let us see the first one, coupling reaction with phenol. Benzene diazonium chloride is treated with N triple bond NCl minus. Benzene diazonium chloride is treated with phenol. So this is phenol, and we need the para hydrogen of phenol. These two together will be removed as HCl in a slightly basic medium at low temperature. We are removing HCl, and then there remains benzene ring, N double bond N. In ISC board correction, presence of HCl is important, as well as showing this N double bond N is important. Yeah, and you get your product, which is called para-hydroxy. So this is your hydroxy group here. Para-hydroxy azobenzene. Para-hydroxy azobenzene, which is an orange color dye. They can either ask this question in filling the blanks, highlighting the color, or this can be asked as a test to distinguish between phenol and some other compound, say aniline, or this can be just asked as the equation as it is, right? Reaction equation for coupling reaction with phenol, benzene diazonium chloride with phenol. Yeah, so this is an important reaction. Look at the reaction. Diazonium chloride treated with phenol. The para hydrogen of phenol is removed along with Cl minus of diazonium chloride, and you are getting para-hydroxy azobenzene, which is an orange color dye. Next reaction that we need to study here is coupling reaction with aniline. So once again, we need to take diazonium chloride, benzene diazonium chloride, N triple bond N, Cl minus. This is benzene diazonium chloride. Treat it with aniline. We need to remove the para-hydrogen of aniline. This reaction requires acid medium. Point to be noted. Phenol's reaction happens in slightly basic or alkaline medium, whereas aniline react in acid medium. So the product will be benzene ring, N double bond N. All right, and you have your aniline here. This is called para-amino. The previous one was para-hydroxy. Para-amino azobenzene. Para-amino azobenzene, which is a yellow color dye. Yeah, so both these coupling reactions result in dyes. Phenol gives orange dye, as well as aniline gives yellow dye. Yeah, that's all about organic compounds containing nitrogen. Stay tuned for more videos. Thank you.